Hey student, welcome back. We've been working on the definition of the derivative and the power rule, but the power rule is a little bit limited, right? We can only work with functions to an exponent, x to a power, for example. Today, I want to show you how we can use the definition of the derivative to find the derivative of sine of x and cosine of x. After today, we won't need to use the definition again to find these derivatives. We can rely on what we know are the derivatives of these functions. Okay, so let's get started. I've already written the limit as h goes to 0 of sine of x plus h minus sine of x over h. So let's continue there. And first, we're going to need to use a trig identity that you learned in pre-calculus. So that is angle sum identity. This becomes sine of x, cosine of h plus sine of h cosine of x minus sine of x all over h. Now we need to be a bit creative, and we're going to separate this into two limits. We're going to have the limit as h goes to 0 of, let's see, we're going to put sine of x cosine of h minus sine of x together all over h. And we're going to add this to the limit as h goes to 0 of sine of h cosine of x all over h. Okay. We've got a little bit more work to do here on the left side. So I'm going to just stick with this left-sided limit for a bit. The limit as h goes to 0 of, we'll factor sine of x out, sine of x cosine of h minus 1 all over h. And since sine of x has no h's in it, we can actually float that all the way to the front of the limit. We can take that out using a limit law. And on the inside, cosine of h minus 1 all over h. We still can't plug in h equals 0. We're going to multiply by the conjugate. So we have cosine h minus 1 all over h times cosine h plus 1 over cosine h plus 1. And sine of x is still on the outside. Limit as h goes to 0. Cosine squared h minus 1 all over h. Cosine h plus 1. Okay, this is getting to be a mouthful. Cosine squared h minus 1, we can use the identity for sine squared h plus cosine squared h equals 1. The Pythagorean identity is sine squared h plus cosine squared h equals 1. So cosine squared minus 1, if we move this around, cosine squared h minus 1 is the same as negative sine squared h. So we can replace the numerator with negative sine squared h. I'll erase that later. We have sine x, the limit as h goes to 0. Here we have negative sine squared h over h times cosine h plus 1. Okay, and this is getting crazy, but here actually, let me go ahead. I'm going to erase this. We've already seen this. That sine squared h over h, it's so much like sine x over x. So we can actually factor out one of these sine h's and then cancel it with h because we know that limit is 1. So let's do that. So sine of x, the limit as h goes to 0, negative sine of h over h times sine of h over cosine h plus 1. Okay, now we can plug in. We know that taking the limit as h goes to 0 of negative sine of h over h is negative 1. And we're still multiplying by sine of x. And the limit as h goes to 0 of sine of h over cosine of h plus 1 is 0 over 2. So this is just 0. This whole term is going to go away. So there was a lot of work for that to just disappear. Now we can go back up and take a look at our second limit that we were working on. I'll give us a new color. Here we were. The limit as h goes to 0 of sine of h cosine x over h. Now we've already seen this. We've already seen sine of h over h. So we can move the cosine x up to the front. Cosine x limit as h goes to 0 of sine of h over h. We know that this limit is 1. So we just have cosine x, 0 plus cosine x, or cosine x. The derivative of sine of x is equal to cosine of x. Okay, we do not have to do that ever again. I wanted you to see it. I think it's interesting to see where it comes from and that we can get this limit, this derivative. But when you're doing this as a student, the derivative of sine of x is cosine of x. That's it. You don't need to worry about this. Here we've got the second part. We can walk through this really quickly. I might even have my editor cut some stuff out of this, but we're going to use the same properties. Cosine x, cosine h, minus sine x, sine h, minus cosine of x, all over h. And we'll separate this into two limits again. Limit as h goes to 0 of cosine x. We're going to factor it out again. Cosine h minus 1 over h minus the limit as h goes to 0 of sine of x, sine of h, all over h. We already saw this with cosine of h minus 1 over h. That limit ended up being 0, right? We had this cosine h minus 1 over h. This whole thing ended up being 0. So we can go ahead and get rid of this term here. This will end up being 0. And we can factor out the sine of x here. And we'll see the limit as h goes to 0, sine h over h, that's 1. This is just negative sine of x. The derivative of cosine of x, d dx, of cosine of x is negative sine of x. This was just to show you that you could derive these. You don't need to do it yourselves. You just need to know the derivative of sine is cosine. The derivative of cosine is negative sine. In the next video, I'm going to show you what the derivatives of tangent, secant, cosecant, and cotangent are. I'll see you in the next one.